Okay, so more proportionality theorems. These aren't necessarily doing proportionality on triangles, okay? It might be parts of triangles or just lines. So here's the first one. We have if one line is parallel to another side of a triangle, then these parts are proportional. So for example, this could be 4 over 2, and this could be 6 over 3, as long as the sides are proportional. Alright, so if we take a look down here, it shows that these two are parallel, so we know that we could write this proportion. We're trying to find this. X over 9 equals 4 over 6. Alright, cross multiply and solve. 36 equals 6x. So x in this case, come on, alright, 6x, there we go. X equals 6. And we're just looking for the length of RQ, which is exactly what I found here. Find the length of YZ. Alright, I'll put an X there. So you have 44 over, and if I felt like it, remember properties of proportions, I could say 44 over 36 equals 35 over X. Alright, or I could have done 44 over 35 equals 36 over X. The only thing I did was change the means here. Alright, so now cross multiply. So 35 times 36 gives us 1260. 44 times x equals 44 times x. Okay, 1260 divided by 44. I don't think that goes in evenly. Alright, so I think you can reduce it to 315 over 11, or about, we could say, for a decimal, this length would be about 28.64. Alright, the converse of that, all this is doing is saying the opposite thing. If you see that these two sides are proportional, you can assume that the lines are parallel. So we're trying to determine whether this is parallel to this. If so, the proportionality should hold true. 90 over 50 should equal 72 over 40. Okay, cross multiply here, so I'll get 3600 equals, and 72 times 50, 3600. Looks like they are equal, so yes, PS is parallel to QR. And then you want to make sure you answer your question. Alright, there are two more extensions or ideas. It could be more than two segments here. Alright, or it might not even have to be in triangles. So if this is 4 and this is 8, this could be 3 and 6. Notice it's not in a triangle, but they have the same proportion. Alright, and down here, if this is 4 and this is 8, then this could be 3 and this could be 6. So AD over GB, 4 over 3 equals 8 over 6. Or 4 over 8 equals 3 over 6. Alright, so there are two sets of problems here. I'll work through this one, and I want you to do the other page on your own. Alright, so we could set this up. 16 over what equals 15 over 18. Cross multiply, we get 15x equals 16 times 18, which we could write as 288. Alright, and then dividing by 15, you can leave it as a decimal simplified, as a fraction simplified, or as a decimal. Either one will do. 19.2. And then see if it's reasonable. It looks like that would be pretty good. Over here, ooh, this is a tough one. 4 over 4. equals 4 square root of 2 over what? The only thing that could make that equal would be if AB was 4 square root of 2. Another tough one. Alright, use the given information to determine whether the lines are parallel. Remember, if they are parallel, then the sides would be proportional. So we could check that. 8 over 5, is that equal to 12 over 7.5? Alright, so multiply, cross multiply, 8 times 7.5, that's 60. 12 times 5, that's 60. So yes, they are parallel because the corresponding parts are proportional. If we check this one, 18 over 24, is that equal to 10 over 15? 24 times 10 will give me 240. Alright, 18 times 15 gives me 270. Are they equal? No, of course not. So no, the lines are not parallel. Alright, so I would like you to do these 4 problems. All you have to do for the first 2, actually there are 3 problems. Good thing I can count. You just have to find the value of x, find the value of y, and then use this multiple choice answers here to solve for the value of x. And then this problem we will save for our in-class activity. Have a great day.